Start. Good morning, student. Today I will start next portion of the surface chemistry. This portion is little important for the course, but important for our life. Catalysis is the second portion. Some substances in the chemical reaction increase the rate of reaction or overall decrease the rate of reaction, or you can say that, or some substances which alter the rate of reaction, alter the rate of reaction are known as catalyst, and process is known as catalysis. Okay, this is the catalysis. some कुछ ऐसे भी सब्सटेंस होते हैं जो केमिकल रिएक्शन में रेट ऑफ रिएक्शन बढ़ा देते हैं, घटा देते हैं, या कह सकते हैं कि जो सब्सटेंस रेट ऑफ रिएक्शन को अल्टर करते हैं, चेंज कर देते हैं, उन्हें हम कैटालिस्ट कहते हैं। उनके इस प्रोसेस को हम कैटालिसिस कहते हैं। तो हम फटाफट इसको कंप्लीट करना चाहेंगे। अब यहाँ पे कैटालिसिस को हम दो पार्ट में डिवाइड कर सकते हैं। ये जो कैटालिसिस है दो पार्ट में डिवाइड हो जाएंगे, बस ज़्यादा लिखेंगे नहीं, थोड़े भी बताएंगे। ये है होमोजीनियस कैटालिसिस, एंड हेटेरोजीनियस कैटालिसिस। Okay. As the name suggests, homo means here is homo means same phase, you can say. If catalyst and reactant both are in same phase, okay, then such catalysis is known as homogeneous catalysis. Okay, example you can take hydrolysis of ester, best example for you, and you have learned in class 10 also. If you take here water, this one also liquid, this one is also liquid, and you take some acid, act as a catalyst. It gives what? It gives CH3 C double O minus N C2H5OH. This is the example of here reactant. Both reactant are in liquid phase. Catalyst is also in liquid phase. There are so many examples of such type of hydrolysis. Now you can take example here. Similarly, hetero means different state, different states or different phase. You can say, suppose means reactant and catalyst are in different phase. Okay. Now you can see the example. Here is H2 plus, sorry, here you will take N2 plus 3H2 gives 2NH3. This one is in gas, this one is gas, this one is gas. Plus here catalyst is iron which is solid. तो बच्चों ने यहाँ पे देखा कि अगर सेम फेज में है तो होमोजेनियस और डिफरेंट फेज में रिएक्टेंट और कैटालिस्ट है तो हेट्रोजीनियस कैटालिस्ट हो गया। तो यहाँ पे इस कैटालिसिस में हम देख रहे हैं आयरन सॉलिड स्टेट में है, एक प्रोमोटर भी लेते हैं एमओ। ओके, तो ये सब सॉलिड स्टेट में है और हमारा जो रिएक्टेंट और प्रोडक्ट है वो सब गैस के फेज में। तो ये हो गया हमारा हेट्रोजीनियस और होमोजीनियस कैटालिसिस। ओके, आई होप समझ में आ गया होगा। ये ज़्यादा हमें नहीं देखना है क्योंकि कोर्स में है नहीं, मगर ये चीज़ें आगे भी डिलीट नहीं रहेंगी। आगे जब आप लोग एंट्रेंस एग्ज़ाम देंगे तो ये सारी चीज़ें मिलेंगी। और सीबीएसई ने कहा है कि जो चीज़ें हमने रिड्यूस की हैं उसे छोड़ना नहीं है, उसे पढ़ाना है, भले पेपर में ना आए क्योंकि इनका अपनी लाइफ में भी इम्पोर्टेंस है। तो हम नेक्स्ट यहाँ पे देखेंगे मैकेनिज्म ऑफ कैटालिसिस। वेरी सिंपल, इज द लॉक एंड की। लॉक एंड की मेथड। First of all, I will tell you something about the enzyme, then catalysis mechanism. Enzymes. These are biocatalysts, which catalyze catalyzes what? Biological reaction. Okay, बायोलॉजिकल रिएक्शन। ठीक है, तो ये जो है कि बायोलॉजिकल रिएक्शन मीन्स जो रिएक्शन हम लोग के बॉडी में, एनिमल में, प्लांट में जो रिएक्शन होते हैं उसको बायोलॉजिकल रिएक्शन कहते हैं। ठीक है, अब फॉर एग्जांपल हम ले सकते हैं यहाँ पे, सपोज दिस वन इज द C12H22O11, this one is the sucrose. Okay, in presence of invertase enzyme, it is converted into C6H12 O6 and C6H12O6. This one is glucose and this one is fructose. Okay, these are two different compounds. So many reactions are catalyzed in body. You can take maltose, malt sugar. In the presence of maltase enzyme, okay, break into n molecule of C6H12, or you can say 2 molecule of C6H12. This one is the glucose. Okay. Similarly, some other enzymes. These are the enzymes which catalyze the biological reaction. Now we can see the characteristic of catalyst. Then we will see the mechanism. First is of catalyst, and both are on enzymes. It also works. Okay. First, these do not react with reactant. Okay, do not react with reactant. Second, after reaction they remain as such. Third, they do not affect effect, or you cannot affect chemical equilibrium. Fourth, these are required in small amount. They are very specific, that is they catalyze a specific type of reaction. They catalyze a specific type of you can write here particular type of reaction. Particular type of reaction. Okay, and last one is that they are selective. So you can say they are selective, means particularly to work for a special type of reagents. So student, there are, and one thing more, they work on optimum temperature and pH. Optimum temperature and pH. Nothing more than this you have to know. These are the characteristics. They do not react with the reactant. After reaction they remain as such. They don't affect the chemical equilibrium. These are acquired in very small amount. and they are specific, that is they catalyze particular type of reaction, they are selective, they work on the optimum pH. Okay, they work on the optimum pH. So these are the about the characteristic of the catalyst. Now mechanism of catalysis. Okay, we will see little mechanism of catalysis. What are the mechanism? First, any suppose we will take here. Suppose this is the reactant A2 plus B2, and this one is the catalyst. Suppose this is the catalyst, because they have some special type of structure. Okay, first they will come to absorb on this catalyst. This is the catalyst. This is the catalyst. First they will get absorbed. Catalyst decrease the activation energy of catalyst decrease the activation energy of catalyst the activation energy of what this reactant. They have high activation energy. When they get absorbed at this surface, then after some time you will see new compound is formed and catalyst will be released. Okay, in the same condition, there will be no change. Okay, this way reactant and catalyst interact to each other. Okay, here is process of adsorption. Here is adsorption and here is desorption. Okay, means here these two are get adsorbed, and here is after formation of product get desorbed, means separated from the complex. Okay, now we will see the mechanism of enzyme catalysis. It is very simple. Mechanism of enzyme catalysis. How it works? You will see here. Enzyme catalysis work on the lock and key mechanism. It is based on lock and key mechanism. ओके, तो यहाँ पे ये लॉक एंड की मैकेनिज्म पे काम करता है। लॉक एंड की मैकेनिज्म का मतलब क्या हो गया, जैसे हम लोग अगर कोई लॉक खोलना होता है तो पहले क्या करते हैं, लॉक अगर क्लोज है तो सपोज करो कि हमारा जो लॉक है वो क्या है, एक सबस्ट्रेट है। वो क्या है, एक सबस्ट्रेट है, यू कैन से रिएक्टेंट है। ओके, तो हम जब उसमें की डालते हैं तो एक कॉम्प्लेक्स बन जाता है, क्योंकि हमने की डाला, उसे घुमाया, अभी पूरी तरह से नहीं घुमाया, तो वो की उसके साथ इंटरेक्टेड है। फिर जब हमने इसे घुमा दिया है तो लॉक क्या हो गया, खुल गया। अब ये लॉक का खुल जाना एक नया प्रोडक्ट बन जाना है। अब की हम निकाल लेंगे, तो की में तो कोई चीज़ नहीं है, की उसी तरह से है। तो एंजाइम भी उसी तरह से क्या करती है, सबस्ट्रेट के साथ इंटरेक्ट करती है। फिर सबस्ट्रेट के साथ इंटरेक्ट करती है जब, तो सबस्ट्रेट को जो उसकी जो एक्टिवेशन एनर्जी होती है उसे कम करती है, उसे प्रोडक्ट के रूप में ब्रेक कर देती है। तो वो दो प्रोडक्ट के रूप में, अलग प्रोडक्ट के रूप में बन के तैयार हो जाता है। तो इसी को हम लॉक एंड की मैकेनिज्म कहते हैं। मीन्स कि जो एंजाइम है पहले सबस्ट्रेट के साथ कॉम्प्लेक्स बनाता है, एंजाइम सबस्ट्रेट कॉम्प्लेक्स बनता है, और वो कॉम्प्लेक्स जब प्रोडक्ट में ब्रेक होता है तो एंजाइम अलग हो जाता है और कॉम्प्लेक्स सब प्रोडक्ट अलग हो जाता है। तो बहुत इजी मैकेनिज्म है। वी कैन सी सपोज दिस वन इज द substrate. Okay, this is our reactant. Okay, now you see here, this one is the enzyme. Okay, this one is the substrate, this one is the enzyme. Enzyme is like the key. Okay, what is like the key? First of all, they combine to each other. Okay, combine to each other. And they will form a complex. See here, suppose this one was the substrate and this is the enzyme. You can take like this, and this one. This is the substrate enzyme complex. After some time, this substrate will break into product, and its shape may be something like this. Okay, and another will be also like this. Whatever may be this is the product. But the enzyme, our enzyme will be same in shape. हमारा जो एंजाइम होगा वो क्या होगा, सेम शेप में होगा, उसमें कोई भी चेंज नहीं आने वाला है। ठीक है, लाइक दिस इज द एंजाइम. This way enzyme work with the substrate. Similarly in our body, enzyme interact with the substrate and then it form the substrate enzyme complex, and after some time substrate converted into product and it leave the enzyme, because the configuration of this product is changed and enzyme will be removed like the key. तो इस तरह से हमने देखा कि किस तरह से एंजाइम लॉक एंड की मेथड पे वर्क करता है। ठीक है, तो इस तरह से हम लोगों ने कैटालिसिस भी देख लिया, और एक हमारा जियोलाइट भी था जिसे हम सेफ सेलेक्टिव कैटालिसिस कहते हैं। नाउ वी विल सी नेक्स्ट टॉपिक. आई हैव completed this in the very short because we have not to learn in detail, but you have to know this, because after some day it will seems that these topics were not in the book, because in the future when you will give the exam competitions of 2021 you will see these topics, questions from these topics also will be there. So CBSE told that don't skip this topic, include, but they are not included in the board examination, but they are important. Okay, now we will start very in little form about the next topic, means third part of the surface chemistry. Okay, what is that? That is the colloidal state. Okay, very important and very good topic for us. Okay, colloidal state. Before that, this we will told you that there are some classifications of compound you have learned in class 11th. Solution, colloid, and suspension. These are the three different type of mixture in which you have learned that solution is very transparent. You cannot separate simply the solute and solvent from the solution by the filtration, simple filtration method. And the size of these particles in the true solution is less than 10 to power minus 9. Okay, and you 10 to power minus 6. Here is solution, and solution is homogeneous mixture. Homogeneous mixture. This side is homogeneous mixture. This is, here is the suspension. Here is the suspension, and the size of suspension is greater than 10 to power minus 6 meter. Okay, this is in the form of meter. Okay, and in between this suspension and solution there is colloid. Next stage is the colloid. Size of colloid ranges between 10 to power minus 9 to 10 to power minus 6 meter, and less than this is solution and less than this, and these two are the heterogeneous mixture. Heterogeneous mixture. Okay, now you have seen some examples in your daily life. Suppose there is a sugar solution, salt solution. You take the example of salt solution, sugar solution, sugar solution. Okay, these are the some examples of this. And for the suspension, you can take example of soil plus water solution, and sand plus water solution, and you can take some medicines suspension for the kid. Okay, these are the suspension. In case of this suspension, we can separate solute and solvent with the help of simple filter paper. But in these two cases, in this case you can see that very difficult to separate solute particles from the solution. But in this case there is some different also. This resembles this also, but due to the size difference it is heterogeneous. Okay, now in the next class We will see colloids in detail. Thank you, student. Okay.